Hello friends, I am Balaji and today I am going to discuss with you about how to use qsort function available in C. It is one of the efficient sorting function used in C. It implements qsort algorithm which we study in our data structure. So it uses divide and conquer techniques to perform sorting, but some of us are not familiar and not convenient to use that QuickSort our own. So we can use qsort to actually use QuickSort without having to any hard code it. So we will see how to use that function. I am using Visual Studio as my IDE. You can use anything. First, in the main function, I create one integer array int a is equal to 100, 88, 44, 111, 77, and then before we actually call qsort, we will first print the element of this a. For that, I am using for loop. You can use while loop or anything else. I am using for loop. For I is equal to 0, I is less than n, I plus plus. Printf %d, d for decimal, a of I. It is right now showing error because we haven't declared and defined I and n. So we will do that int I comma n. And then we also want to give value to this n to the size of this array. N is equal to 5, or instead of actually specifying 5 elements, we can use the size of operator to get the size of that array. So size of a. Right now we are using size of a. Size of a in our case is what? Here we are having 5 elements. So whether it will return 5 or something else, we will first check it out. %d n is equal to %d and then n. Get char to actually pause the execution to view the result. You can see now the size of n is not actually 5, it is 20. Why it is 20? We have passed only 5 argument to a. So why it's actually getting the value as 20? It's because the size of operator will not return this number of elements present in that array, but it actually passed total number of bytes used by this a. Total number of bytes means here we are using integer array. The size of every integer is 4. Here we are passing 5 integer. So 4 into 5 is equal to 20. So only it is getting 20 as n's value. Here we didn't want 20 as n's value, but we actually want only 5. So how to get it as 5? Size of a divided by size of int. Size of integer in my case is 4. If you are using turbo C, it will be 2. So only I am passing size of int. Size of a what? 20. Size of int what? 4. So 20 by 4 is equal to 5. We will now run it. Now you can see size of a will be 4, and then the loop iterates only for 5 times. So only it didn't print any unnecessary garbage values, which you see in our previous case. And I will use one printf to make better visual before sort. and then after calling QuickSort we also once again want to call this function to see our result. Now we will call qsort function. Qsort function is available in a header file called stdlib, means standard library.h. We will include it as include stdlib.h. Now I will call qsort. Visual Studio is showing intelligence for me. The first argument is base pointer of the array which we want to sort. Here the array which we want to sort is A, so passing A will give me the base address of that array, means the size of the first argument present in that array. Not size, it's actually a starting byte of first argument. Here in our case is 100 is the starting argument, so it will pass the base address of that 100. Since the array is stored in continuous memory location, we can access each bytes continuously. So I am passing A as the base pointer, and then the second argument here is number of elements. Number of elements means how many elements are present in our array? N elements. N elements means we actually calculate the value of n here, so we want to pass n. Then size of each element. Why it is actually necessary? Here we actually pass size of total number of elements, so that only it can able to retrieve that much element and then it can able to print it out. But why we actually want that size of each element as a third argument? Because when we are using pointer, each pointer arithmetic will increment the pointer as the size of that data. Here we will actually go to the definition of that QuickSort. Right click it, go to definition. Here we actually pass A to this base pointer, to this base argument. What is the data type of it? It is void, means in our case we are passing integer as the size as the type of that argument, but it uses a generic pointer called void. So and then it receives the size of total number of elements in size t, means it's a type def unsigned integer, and then we are passing size of each element. Why it is necessary means because suppose consider int star p. When I increment p, how much bytes it will increment? It will increment for 4 times 4 bytes, because the size of integer is size of because the type of p is integer and then the size of integer is 4 bytes. Now if I use character means how much time the p will increment, how much byte the p will increment? It will increment for 1 byte only, because p's type is character and the character size is 1. So the pointer will increment for the size of its data type. In our case, the size of our database integer is 4. So but it receives that A in void pointer to make this function generic. So we want to pass the size of integer as the third argument to specify how much time it should increment. We actually guide that QuickSort, we are using integer, so increment the pointer for each time as a 4 byte. So the third argument is size of what? Integer. And then the last argument here is comparison function. It is showing comparison function. So what is this comparison function? Why it's actually necessary? This comparison function makes our QSort to work more flexible, because using QSort we can sort any kind of data, because it collects our data in void pointer. Into void pointer we can pass integer, float, character. We can actually pass any type of data. So what QSort say is, you give me the address of comparison function, I will call this function on because of you. Means we only actually want to say this QSort how to perform comparison between two arguments, because they because we only pass the data to this QSort. QSort didn't know about what is the data type of that array, because it used void pointer. So for each data type the comparison may be different, and then the way we are comparing also differs. So only we want to guide the QSort function with our comparison function. The QSort will call our comparison function whenever it's necessary. So only it receives the last argument is as our comparison function. So here we are calling QSort, and the QSort calls our comparison function. This is known as callback mechanism. Means we are calling QuickSort back calls our function, so it's known as callback mechanism. We will pass address of our function. Before that we actually create one function which receives two constant void pointer. Int my comparison void star x void star y. Why we are passing void pointer here? Because QSort collects our data only in void pointer, so only we are receiving it in two void pointers. And then the return type of it is integer, because after doing some comparison between this x and y, the result will be the integer value. So only we are specifying result as integer, and then we pass address of this function to QSort. How to get address of this function? If we if we use the function with parenthesis, mean it will actually call that function. But if we didn't use this parenthesis, means it will retrieve the address of that function. So we will assign it to here. Here right now it is showing some error, because we have passed argument type as wrong. It is not actually void star x, it's actually constant void star x. Means in the comparison function we didn't have any permission to change the value of x and y. We actually want to get the value of x and y, and then we want to compare it, and then we want to return the value. But we didn't have any permission to change the value of x and y. So pass constant as qualifier for this void pointer. Now the error has gone. Now we want to define our function. We want to collect it out. Collect the data present in x and y. Int. For that, first I declare two integer pointer, star xx comma star yy. Xx equal to x, yy is equal to y. And then To store the value of the comparison, I use result is equal to xx star xx means value present in xx minus value present in yy. If we simply use xx minus yy means it will actually compares the address of x and address of y. We didn't want to find the difference between the address, but we want to find the difference between the value present inside that address. Inside that address means value of that address. Value of address where operator is star. So I am using star xx minus star yy. And then I want to return back to qsort, return result. Right now here it is showing error. Why? Because here the type of x and y is void pointer, but we are using integer pointer. We will typecast it to integer pointer, int star, int star. Now I run this function. Everything is right. So see here, the formatting is not that much nice, so I will just format it again. /n for new line, /t for tab. So before we actually call QuickSort, the value of A is 100, 88, 44, 111 and 77. But after calling QuickSort, we get the data in sorted order. So now we will use this same function to print the data in descending order. But before we actually do that, we will explore how this qsort function works. When does it change the data? Whether it actually calls our my comparison function. So I will keep some breakpoint here. I will keep breakpoint in our comparison function. So whenever the control enters here, our code will be break, and then we can monitor the value of each variable. Now I run this program. So the code breaks here. Now what is the value of x? The value of x is actually 88. Value of y is 100. Means the first two arguments gets passed to this function, and then we are actually finding difference of 88 and 100. The result is minus 12. The qsort here in this case actually exchange data only if the result is greater than 0. Means if the first argument is greater than the second argument, then only it will exchange the data. So here in our case the first argument is 88, second argument is 100. If here the data is actually in sorted order, so if we find difference between these two arguments, mean it will return the negative value. So here the sorting didn't want to happen. But if the first argument is 100 and the second argument is 88, means here we, in this case, we actually want to perform sort. So here the difference between 100 and 88 is also greater than 0. See, so we actually want to swap that element. So the qsort receives this return argument. If the result is greater than 0, it will perform the sort, or it will not perform the sort. It will go to the next element. I will continue. Now we will see the value of x. Now the value of x is 44 and the value of y is again 100. Means 44 and 100. Then I will continue it. Now the value of 111 value is 111. Value of y is again 100. 111 and 100. Now 77, 111, 77 here, 111. Likewise it go on continue until all elements get shorted. I will remove this breakpoint. Continue. Now we get the shorted order. So now we will see how to use the same qsort function to perform to actually sort the array in descending order. Here we sort the array elements in ascending order. Now we will see how to sort the array A in descending order using the same function qsort. I actually said we only want to guide the qsort how to perform comparison between two elements. So we will modify our comparison slightly to produce different results. I will copy this and then I will paste it here. I will change this name to comparison function descending order. All these steps here are same, but here we want to modify it slightly. Instead of star xx minus star yy, we want to put star yy minus star xx. Means if the first argument here is 100 and the second argument here is 88, means it will first do 88 minus 100. 88 minus 100 means the result will not be greater than 0, so it will not actually swap the elements. But if the first argument is 88 and the second argument is 100, means now we actually want to swap the element, because we want to perform our computation in descending order. We actually want to perform the sorting in descending order. So in our case star yy is 100 and star yy is 100 and star xx is 88. So the result of this both is 88 minus 100 is 100 minus 88 is a positive value. So in this case 100 and 88 gets swapped, and then 100 goes up and 88 comes down. So by modifying this single line, we can actually modify the way it's short. So only the qsort is a generic function which is used to sort any type of data, and then it can actually sort both in ascending and descending order. Now we will check this function whether it will work or not. First I declare this function. After sorting in ascending order, I will call these functions again. Sorting in descending. Instead of our my comparison function, we want to call my comparison function desc. Now we are in this program. See, here our array again gets sorted to descending order. So this is the utility of qsort. We can use this one function to sort any type of data, and then we can actually sort both in ascending and descending order. So thank you for viewing this tutorial, and then subscribe to my channel. Thank you.